All right, good morning, everyone. I certainly hope all of you are having a good day today. Looks like the rain might let up here and might have a good weekend after all. We'll certainly see about that. A couple quick announcements before we jump into everything. So I sent out an email earlier today. Did everyone receive it? Okay, just kind of go over it briefly. The quizzes are going to be due Thursday at 11:59 p.m. Make sure you do them before then. And beyond that, I did send out a survey link if you have any questions about anything from chapter or for units 2. So that includes all the chapters we've had, which are, let's see, I don't remember the chapter numbers off the top of my head. Chapter 7, e-business and e-commerce. Chapter 4, information security. Chapter 9, social computing. Chapter 5, data and knowledge management. And then today, of course, we'll be covering chapter 13, acquiring information systems and applications, and we'll also cover Technology 2 Guide for software. So any questions about any of those, certainly fair game. Of course, you don't have to limit your questions to that if you don't want to, but generally speaking, I'd advise that you keep it to Unit 2. Just to make sure that it's not asking anything too out there, but ask whatever. So certainly make sure you do that. Beyond that, any questions before we begin Chapter 13? Okay, so chapter 13 is a very important chapter. So up to this point, we've kind of discussed what information systems are. We've gone through some of the basic concepts about things like security, data management. What we haven't really covered so far, though, is how do we actually acquire information systems? So the basic level, you can imagine, there's a couple different ways we could do this. We could develop something internally, certainly fair game, but that doesn't usually make sense for a firm to do, particularly if they're not inside of the IT sector. Because if they're developing something internally, it's going to cost, in most cases, more because they're not going to be able to realize any sort of economies of scale. So in general, if you were to develop some sort of any innovation, if you can only use it for your one company, you don't realize that advantage of being able to offer the same thing to a multitude of different providers. So think about it like this. If you have a document, and let's say it's an electronic document, and you send it to 50 people, is there a very high marginal cost in sending it to an additional person? There's not. So generally speaking, developing the document, writing a paper in the first place, that's a very high marginal cost to do one paper. But sending that to additional people, very low. The same thing with software. So if you were to purchase software that's pre-written, it's a very low marginal cost to the software developers. But it's a very high upfront initial cost to develop in the first place. So that's kind of the things we'll be talking about today. So specifically, we'll be covering IT planning, go through the different processes that an organization may use to plan their IT expenditures, to plan their IT strategy, all that sort of stuff. We'll also talk about sourcing applications. So that's a very important topic to understand when is the best place and where are the best places to source applications from. And then lastly, we'll cover some basic development approaches if you were to choose to develop something internally. So I've got a quick little video here. Just going to introduce things a little bit for us. It's a Dilbert clip. I'm going to go ahead and mute the recording here. All right. Any thoughts on that video? Well, I think it's kind of a funny way to introduce the topics for today, which are sourcing applications and going through and really developing something. So in that case, they're developing hardware. It's developing a power supply. And if you'll notice from the video, stuck a nail in a piece of wood. Is that going to be a functional power supply? It's not. It's not an electrical engineering class, but just kind of intuitively, there's no way that's going to work. So having the thing actually meet what it's supposed to is a very important part of anything that you're doing. So imagine if you were to go through and you were to say, I want to buy a car. So you go out, you look for car models, and you have your specifications. Well, would you say, instead of buying a car, I think I'm just going to buy a new pair of tennis shoes? Is that going to fulfill the same requirements that a car would fulfill? Not unless you're quite a bit faster than I am. Let me tell you, I think you'd have to be quite a bit faster than anything living. So, certainly you have to make sure that whatever you're doing is fulfilling the requirements for whatever you have set out to. So let's take a quick look at the strategic planning cycle, because from a business standpoint, it's very important that we consider the strategy of the organization that we're a part of. So at the very top, we have goals. And goals, of course, being, what do we want to accomplish? And then, we kind of go clockwise a little bit there. We get to desired outcomes. What does it mean to have accomplished the goals? What are the specific measurable outcomes there? We have the strategies. How are we going to accomplish them? So we know what to accomplish. Strategies tell us how to accomplish it. We have the measures and targets. It's going to be even more specific than before. So we have exact measures along the way for this approach. This is how we're going to measure it. Lastly, we get the results. And of course, the results are, did we meet them? Did we not? So once we've done that, it's a cycle. We go back and see how we could improve, what we did well, all that sort of stuff. And of course, central to all of this strategic planning cycle is going to be the mission. Mission being, of course, what does the organization do? Why are they in business? If it's a nonprofit, I guess, why do they exist? That's what the mission statement is. It basically says that. So from an IT standpoint, we want to make sure that anything that we're doing in terms of developing systems, implementing systems, providing technology to customers, to users, we want to make sure that it aligns with organizational strategy. And the main reason for that is, how are you going to get upper level buy-in if what you're doing doesn't align with the organization? So let's back up a little bit. Imagine we are a motel chain. Let's just use any motel chain, for example. Would you want to have extremely high-end technology inside of motel rooms for clients to use? Say you're a $40 a night place. Probably wouldn't make a lot of sense to do that, would it? Let's say we are a very high-end chain. To take your high-end hotel chain of choice, then it may make more sense to do that. So you definitely want to make sure that whatever sort of IT investments you're having, they're aligned well with the organization's strategy. It's not just about making sure that the upper level management agrees. It's also making sure that you have buy-in from all levels of the organization. So that includes anywhere from regular employees all the way up to top executives, but also customers. Have there been cases where customers didn't buy in to a particular organization's information systems? I can think of several. I think we gave an example earlier in the semester where we had the Seinfeld clip where they had Kramer saying, why does Radio Shack ask for your number when you buy batteries? That's an example of people not buying in to an organization's information system. So if we approach it from that perspective, we want to make sure that whatever we're doing aligns with the organization itself. But then really the whole purpose of this strategic plan is to say, this is the architecture we're going to offer for the firm. So this is going to include things like what sort of server infrastructure we're going to have, network infrastructure, at a basic level, what devices. The strategic plan is not generally going to cover each and every device because strategic would be very high level. It's not going to be low level decisions like which desktop model do we go with. But basically what this is all about is taking the overall budget that we have and any other sort of resources, and it's determining how are we going to allocate this. Now, again, this is not going to be some budget where we break down each and every dollar. Rather, it's going to be a high-level budget where in the general sense we're going to allocate funds from one project to another. So that's basically what we're talking about here. So getting a little bit more specific, in the strategic plan, very high level. We have an operational plan for information systems as well. This is going to be a lot more low level. We talk about specific devices. We talk about specific purchases. That's going to be found inside the operational plan. So, in the basic sense, we're going to start off with some sort of mission statement, which, generally speaking, that should definitely align with the organization's mission statement. So, pretty simple there. Just find out what your organization's mission statement is. and make an IS statement that aligns with it. Then you're going to go through, break down the general IS environment. This is where you would cover things like any sort of major infrastructure that you have, any sort of major applications that you're using to support the primary business activities. And arguably, you could support the support activities with these as well. But generally speaking, we're going to focus in the environment section on the primary business activity, because that's what the organization is doing to make money. Support activities inherently don't make the organization money. At best, they can keep it from losing money. Of course, we have the objectives. There's going to be the statements about what are we doing, and then we break that down a little bit further. We say, what sort of limitations do we have? Do we have budgetary constraints? Do we have constraints on physical space? Do we have constraints on personnel? Lots of different things could be a factor in determining what we can or cannot do. So imagine we had an organization and they said, this is the only space we can have for the next 5 years. Well, and we may want to put a data center in. How can we do that? Well, the most easy solution would be to use something like a third-party cloud-hosted solution. That's going to pretty much solve every problem we could have and give us the opportunity to still engage in the same level of technological services that we otherwise would be able to with more space. So just because you don't have a particular resource doesn't necessarily mean that something is impossible. It just means that you have to figure out another way to accomplish it beyond what would be considered conventional. Of course, at this point, I would argue that using third-party providers is pretty conventional, but you can make an argument it's not. And again, that's sort of splitting hairs there. So I said, the IS environment includes the very high-level applications, the stuff that's used across the organization, or the stuff that's used for primary business activities. The application portfolio is every application. And specifically, this includes information about the application name, what sort of licensing agreement we have, what we're paying for it, where the funding is coming from for it, where it's installed, how to install it, versions, any sort of vulnerabilities that exist within the application, any sort of notes like that. Going to be included in the application portfolio. It's going to be very detailed. Generally speaking, an organization is probably going to have at least dozens of applications, if not hundreds. And different organizations manage them in different ways, but generally speaking, having this information in a central spot is going to be very advantageous to the firm and allow it to more easily and effectively provide application support to its users. And then, of course, we have resource allocation. So this is where we're going to break down the budget by line item. So basically, in the strategic plan here, we have a very high-level budget. In the operational plan, we have a very detailed budget. This is going to have each and every expenditure and revenue that the firm has regarding to the information systems. So certainly going to be pretty detailed there. And then lastly, project management. So in the strategic plan, we have an overview of the projects. But inside the operational plan, we have the specific projects. We have very detailed information about them, any sort of project documents, all that sort of stuff. This is all going to be managed inside of the operational plan. So does that make sense between the strategic plan and the operational plan? All right, let's talk about projects a little bit more. So I said earlier in the class that, generally speaking, we want to make sure that whatever project we engage in actually fulfills its goals. So if we were to make a power supply, we would want it to function effectively as a power supply. Failure to do that would imply that it's not going to be very usable to us. So there's a couple other things we also want to keep an eye on with projects as well. Cost and time. So the scope is being, what does the project do? And time being, how long does it take us to accomplish that? And then lastly, we want to keep an eye on cost. How much does it cost to have the project be completed? So the general idea with the triple constraint that we see here is that we can maximize two of these three. So we could have something that is very quick to accomplish and very inexpensive, but the downfall is going to be it may not do very much. We could have something that is going to be, does everything we need it to, possibly some additional things, and it could certainly also be done very quickly, but what's the downfall going to be? It's going to be very costly to do that. Of course, we can see the same thing with cost and scope. So we could have something that is very inexpensive. It could have something that fulfills all the needs, meets the scope. But the downfall is going to be, it's going to take a lot of time to do that. So those are generally speaking the three constraints. It's called the triple constraint model. And the whole idea is that most organizations can maximize two of these three. It's very difficult to maximize all three, if not impossible. So does that make sense? All right, let's talk a little bit more about comparing projects. It's very common for organizations to have various projects pitched to them by different functional units within inside the organization. And you have to figure out some way to compare them. So there's a lot of different ways. I've got three financial measures on here. Net present value. So any finance measures in here? Tell me about net present value. All right, I guess I will. So net present value, you're just looking at the future returns of something. It's a lot more complicated than that, but this is a managerial class, and it's not even a finance class at that. So just know it's looking at future values, seeing based on what we see right now, what we expect to see in the return, which project is going to yield the greatest return is what we're expecting to see. And then, of course, we also have return on investment. So that's basically just going to see, what sort of percentage return do we anticipate receiving with a project? And generally speaking, we'd want to see that the number be very high. So if we were to compare on net present value, we'd be looking and comparing two or more projects and seeing which one's going to give us the max return in a given amount of time. Whereas with return on investment, we'd be comparing two or more projects, but we'd be looking and seeing which is going to give us the greatest percentage return over time. And then the last financial measure I have up here is going to be break-even analysis. And that's going to see at what point do the expenses equal the benefits. So in other words, what point do we break even on what we've spent? And generally speaking, we'd want to see that number be 24 months or less. If it's greater than 24 months, a lot of organizations are not going to be interested in pursuing the project simply because 24 months is a long time from a business standpoint. And to tie up the money in that way for that length of time is going to be very damaging to the organization. So generally speaking, you'd want to avoid anything longer than that period. However, there could be some exceptions. What if there's a case where you never break even? Would the organization ever want to do a project like that? There could be a lot of cases where that will be the case. Imagine there's a regulatory change. The organization pretty much doesn't have a choice but to engage in a project to ensure regulatory compliance in that instance. So there could also be cases where they could do something for goodwill. Maybe they want to do some sort of charitable thing. That could be a project, and it may be that it makes sense for the firm to engage in it, even if they don't break even from a financial standpoint. So, break even is going to be less often used. Generally speaking, you're not just going to use one measure to compare projects. It's generally advisable to use multiple measures, kind of see from different perspectives, because each of these numbers is telling you different things. Similar, but not the same. And then lastly, we have the business case analysis. And, business cases. So what you're doing here is basically just breaking down whatever your options are into a formal business report. And you're providing a lot more qualitative information regarding them. You could certainly also include quantitative information inside of a business case. But basically the whole idea is you're taking what you have right now, which is doing nothing, and you're comparing it to whatever the alternatives would be. So maybe you wanted to replace a phone system. So you can say, if we do nothing, this is what we expect to see in terms of financial performance, in terms of expenses, in terms of anything regarding that. Maybe you're having a problem with dropped calls. Maybe you're having a problem with poor call quality. I don't really know. But you'd talk about that inside the business case. Then you'd find two or three alternatives, maybe a little more alternatives. You could do 4 or 5 if you wanted. No real limitation there. But then you just basically break down, this is what we expect to see with option 1. Maybe we'd see a lower upfront cost, but maybe a higher operational cost. So just kind of break it down in that way. Then you compare them, and ultimately you're going to make some sort of a recommendation at the end. Recommendation may or may not be taken. Organizations can choose to do whatever they want, basically. So, keep that in mind. Just because you recommend something doesn't mean it will inherently take place. So, is that clear to everyone? All right. Another thing to consider is a resource-based view. So we've talked about the allocation of information systems resources. And we talked about the budget, talked about the people a little bit. But it's important to kind of consider this from a theoretical perspective. So we have the resource base. Very famous theory by Barney and some others that kind of goes through, and that's J. Barney, not Barney the dinosaur. Don't want to confuse anyone with that. Very different sort of thing there. Anyway, so what we're doing with the resource-based view, we're allocating resources. So what we have here is we have the resource complementaries. So whatever the resources can do together, and we want to see what sort of dynamic capabilities do they have. So a dynamic capability being some sort of a capability that's not a static capability. It can change depending upon the circumstances. So information technology is generally thought to be a dynamic capability because it can be easily adopted and changed to various circumstances. So then, of course, we want to see what is that going to give us for the advantages. Is this going to allow us an advantage? And that's an interesting topic. Generally speaking, information technology is not going to grant a firm any sort of advantage. And we talked about this in Unit 1 a little bit, but the whole concept is it's ubiquitous. It's a commodity. You cannot achieve an advantage with a commodity because by definition, anyone can go out and purchase exactly what you have. So imagine if I were someone who cared a lot about fashion. And just let's say, for example, I didn't want anyone in here to be able to dress like I do. I don't personally care how people dress in here, but let's just say, for example, I did care. Would I go down to Belk and purchase shirts, or would I make them myself? I'd have to make them myself. That way, no one could go down and purchase the exact same shirt that I have. I'm kidding. I don't want anyone to get the wrong idea. I don't care what people wear. But I'm just saying, there are people who do. And certainly, that's an example of where you cannot achieve an advantage without doing the R&D on your own from a firm standpoint. So you cannot purchase a competitive advantage. You can only develop a competitive advantage. That's all this is really saying here, is that we have to keep that in mind to achieve a competitive advantage. Certainly strategy is going to factor in and all that. But the whole concept is, if we have something that anyone can go out and receive, by definition, it's not going to provide us any sort of advantage at all. It's not to say we shouldn't engage in it. We can certainly see things like reduction in, something like, expenses. That's going to be advantageous. If we can make our processes more efficient, that's going to save us money. That's going to allow us to reduce maybe prices, maybe reduce anything we wanted to, but that's not going to provide us an advantage because any other firm can easily go out and achieve it. Could it provide us an advantage for maybe 1 quarter? Possibly, but generally when we're talking about advantage, we want something that's going to be sustained. So let's kind of keep that in mind there. So we're thinking about what sort of new IT projects we should do. It's always important to consider, what is going to give us those dynamic capabilities that other firms don't have. But that may not be meaningful to us. If we're not an IT firm, what difference does it make? Not really much of any. So generally speaking, that's something we consider for any sort of new expense, but it's not something that we would consider as being, we have to have this advantage, because generally speaking, you're only going to want to achieve advantages from your primary business activity. If it's a support activity, sure, the only real advantage you want to achieve is a reduction in the cost. So that's certainly something to keep in mind. So we want to think about the budget. Certainly think about all aspects of the budget. If we tie up $100,000 of $1 million budget, what is that going to do for us? Is that going to make us more or less likely to become insolvent? Those are certainly considerations to think about. We're talking about IT specifically. Where are we going to put it? Is it a piece of hardware? Is it an application? Where are we going to put it? Who's going to maintain it? Who is going to do any sort of support on it? These are all things that are important to think about. And then lastly, where are we going to obtain it from? So are we going to purchase it from a reputable supplier? Are we going to go to a back alley and purchase something? Generally speaking, we definitely want to purchase from a reputable supplier for many different reasons. Most of them pretty obvious there. But generally, having the ability to have support post-sale is going to be very important, particularly if we're an organization that relies upon this for effective operation. So speaking of where we can actually acquire software, there's about 5 or 6 different major approaches we could take. So commercial off-the-shelf software is going to be the most basic one. You're probably pretty familiar with it. You can walk down to an office supply store, pick up a license for something like Microsoft Office or Quicken, and you're basically good to go. Now you want to make sure that your license allows you to use it in commercial settings, but for the most part, if you do that, it's going to be the same application, between one organization and another. And that provides some advantages, provides some disadvantages. Major advantage being people are familiar with it. If you get an employee, chances are they've used Microsoft Word. Chances are they've used Microsoft Excel. Disadvantages would be things like you cannot achieve an advantage with that. But that's going to be true for most of these. And of course, turnkey software is going to be a little bit more difficult to acquire, but not much more. So basically, the difference between commercial off-the-shelf software and turnkey software is basically an entire appliance. So you go out and you purchase something, it includes the hardware and the software needed to run it. In terms of that, it's going to be a little bit more costly in most cases because there's going to be a lot more overhead associated with it. And generally speaking, it's going to be a lot more niche. You're not going to have any sort of major turnkey application. It's going to be used by millions and millions of people, as some of the commercial off-the-shelf applications would be. In-house development, we're going to talk about in a couple slides here, but the whole concept is that we're developing whatever we're using internally. So this is something we can achieve an advantage from, because if we engage in the proper intellectual property protections like copyright and patenting, then whatever we engage in is going to be ours, and no other firm can easily acquire it. So that's certainly going to provide us, well, it has the ability, rather, to provide us with an advantage. It does not have to provide us any advantage at all, though. Then, of course, we have customized application. It can be pretty common in, like, the ERP sector, where we have some general sort of framework, but then we can customize approaches with the application itself. And ultimately, what we end up seeing is something that's going to be pretty different from organization to organization. We have software as a service. That's just going to be where it's hosted by a third party. So we don't have to worry about installing anything. Just open up a web browser, navigate to it, we're good to go. Then lastly, open source. So open source is a common misconception that it translates to free. But in truth, open source has nothing to do with the price of it. Generally speaking, it means that the source code can be accessed. So hypothetically, you could charge for an open source application. People do. There's lots of organizations out there where they actually provide service agreements and support in exchange for, of course, money, and then they provide you with the open source application. There's absolutely nothing stopping you, though, in most cases, from downloading the source and then just compiling it yourself and running it in that way. What is stopping you is you don't get that support. So generally speaking, what you're paying for with an open source application, if you pay for it, is you're paying for some sort of support agreement. And that's not so important for an individual, because if something breaks, oh well. But if you're a firm and you have, let's just say tens of millions of dollars, maybe hundreds of millions of dollars, riding on some application working properly, that's going to be a lot bigger of an issue. So you definitely want to make sure that you have the support agreements in place. So kind of going into what's the difference between all these, there is no one answer for what a particular application is, just based upon it. But we have some general sort of guidelines we may want to consider when we're comparing applications. Cost. Cost being a very large component. How much does something cost for us to use it? How much does it cost to purchase it? Is there going to be any sort of maintenance fee associated with it? Is it a one-time thing? Is it a monthly thing? Whatever the case is, we want to make sure that we're getting a good picture on what an application will cost us. And of course, we have the support, like I just discussed. Making sure that we can get support from people who know what they're doing for a specific application can be very beneficial for us, because not only can it reduce the downtime we experience, but it can also reduce the cost of providing the stuff internally. Because think back to the one I talked earlier about the economies of scale. If you have one organization, let's say 1,000 employees, and you want to do a new application, you may have to hire a support personnel specific to that application. But are you always going to need support for that given application? Hopefully not. If you are, then well, you probably picked the wrong application. But if you don't constantly need support, it means you have downtime. If you're going with a support agreement, you're not having that problem, because you're getting it to where you may have a pool of hundreds or thousands of support personnel, and generally speaking, you're not having to pay for what you're not using. And of course, that's not entirely true, but in general, you would anticipate it being cheaper to pay into a support agreement than you would see to have it hosted internally, just in a general sense. Location. This would be very important, particularly for smaller firms, where they may not have the space to have anything hosted locally. So making sure we have the ability to install things in a third party would be very beneficial. Of course, you can make an argument that pretty much any of these can be installed on a software as a service provider, at least in terms of the cloud technologies, which we'll talk about in Technology Guide 3. So don't focus on that too much. Also want to discuss security a little bit, making sure that there are clear guidelines for who owns the data, making sure that there are clear guidelines for how the data is used, all that sort of stuff. We generally accomplish those through 2 or 3 types of documents. Memorandums of understanding, basically going to be a legal agreement between 2 or more parties, where both parties agree to how things will be done, basically. So they will take the documentation and basically write it up in a way to where both parties understand these are regulatory requirements that we're subject to, this is the sort of information we will have, this is how it will be secured, all that sort of stuff, maintaining it, all that will be covered. Similar thing can occur inside of what's called a service level agreement. So a service level agreement will be an agreement between 2 or more parties in which they agree to some sort of a service that they will be providing, be it updating, be it maintaining, patching, all that sort of stuff. And then just making sure that there's a very clear guideline for who is responsible for various tasks associated with the software. Again, that's going to be done in the service level agreement in particular. Any questions about this so far? All right, certainly feel free to ask any questions if you have them. I'm going to shift gears a little bit now, though, and talk about developing applications internally. So again, generally speaking, this is inadvisable for a lot of different reasons. The main one being it's more costly than using something that someone else has created, and most firms are not going to need to have a competitive advantage from their information systems anyway. But let's just go through this anyway. So with SDLC, what we're trying to do is we're trying to develop applications that are going to fulfill whatever our requirements are. And the very first step of SDLC is the requirements analysis. So what we do inside of requirements analysis, we meet with each of the different parties that are going to have some sort of a stake inside of whatever we're developing. So let's say we're developing let's say an attendance system. So key stakeholders in the case of an attendance system would be stuff like maybe the IT department, maybe some instructors, maybe administrators. Anyone who has that sort of a stake in attendance system would be included with inside the requirements analysis. And what you're trying to do there is see what does the system need to accomplish. And this is an important phase because there could be a concept where if you don't do a good job at this and you don't gather an accurate representation of what a system should or should not do, it can lead to what's called scope creep. And scope creep occurs whenever, over time, the scope is increased beyond what was originally agreed to. So from a system design perspective, this is a very important phase to make sure that all the parties are in agreement upon what the system should do. Then once you have that done, you start building it. That's the design phase. So not only do you design it from a theoretical perspective, you also then build a prototype that's going to pretty much do whatever you need it to, because the very next thing you do is you implement it. So that's where you actually put it into practice. Now, you don't necessarily put 100% of people on it day one, but you will begin to implement that in a way. We'll talk about some implementation approaches here in a couple slides. Then once you've implemented it, you don't just say, well, we're done. You then test it. Make sure that it's going to not have any sort of issues. Certainly you'd want to take feedback during this phase. And then once you've done all that, you've sort of seen how does it respond, how do users like it, if anything we missed, anything that's not working properly. That's going to be inside the evolution phase. So then inside the evolution phase, maybe you make new versions of it. You provide it with additional capabilities that it doesn't currently have. You fix any sort of problems. And then you go back to requirements phase. So this is a sort of a life cycle where it goes from one phase to the next sort of repetitively. So that's all we're talking about with SDLC here. We just went through those. So let's talk about the implementation strategies. And I wouldn't use the term strategies here. I'd use the term approaches personally, but I made the slides, so I guess I kind of talking bad about myself. So we have 4 different approaches that we can take when we're implementing. And these are 4 major approaches. There's really a multitude of approaches we could take. Let's just go through each of these, though. So what I'm going to do is I'm going to use one color for the existing old system. I'm going to use a different color for the new system. So basically what we're doing is we're seeing 100% implemented or 0% implemented. So basically, what we're going to see here is what does this look like for a direct implementation. So with a direct implementation, what we have is we have the old system that we're using. I'm going to use this red color here. And we're using it 100% until one day we flip a switch and we no longer use the old system. So the old system is now being used at 0% until the end of time, basically. And then in contrast, we have the new system that is going to be used 0% until that day occurs where it flips. So again, pretend this is drawn perfectly. It's not going to be drawn quite perfectly, but just pretend. So it's going to be then used 100%. So we basically went from using the old system 100% to using the new system 100% with no sort of in-between period. Does that make sense? So, think about it as if you were using a website and all of a sudden they rolled out a change to everybody the next day. That'd be this direct approach here. And then we have the pilot approach. So as the name would imply, with the pilot approach, we're going to start off at 100%, but then we're going to do some sort of a pilot testing period. So we're going to put maybe 10% of people, maybe an entire functional unit within inside the organization, on whatever the new system may be, and we're going to then use that. So certainly that's what we're doing with the pilot approach. And then once the pilot testing period is done, we flip a switch just like with direct, and we go to using the new system exclusively. So we're just taking one little step there where we start off not using the new system. We use it for the pilot testing. If that goes well, we're going to just implement this thing 100%, and all will be good. So is that clear to everyone? All right, like I said, feel free to stop me with any questions. Something's not clear or whatever. So we have two more with the phased approach. So as a phased approach would suggest, we're going to do this in phases. We're going to have the old system used 100%. We're going to move some people off of it onto the new system, and just keep doing that, like a stair-step pattern where, until ultimately no one is left using the old system, and the old system can be shut down. So again, we're going to start off at 100%, just kind of, have some people move off of it onto the new system, some more people, even more people, and so on until no one left on the old system anymore. And then in contrast, as you would guess, the new system is going to have the inverse of that. So people are going to, start accessing it, and then, basically this could be any way we want to do it. It could be random. It could be certainly a case where we have one functional unit at a time. No real guidelines as to how we would do this. This is going to be specific to the project itself. So the last thing I want to talk about is parallel conversion. And I wouldn't even necessarily call this one conversion at all, because all we're doing is we're saying both systems are going to be used to their fullest extent, 100%. So what we see here is we see the old system is at 100% utilization. And we also see that the new system is also, we'll just pretend that's 100%. I know it's not exact, but both systems are being used simultaneously. There will eventually be a case where the old system will be deprecated, but it hasn't happened yet. And generally speaking, that could be years. So, generally speaking, when we're representing that, it's just going to be something that's going to be used constantly. I'm pretty sure I have this document published inside of the Canvas course. If not, I'll be sure to post something to represent this. But is that clear to everyone, the four major approaches we can take to implement a new system? All right. I mean, the main thing here is just make sure you let the names guide you. Direct, just taking that one cutoff, pretty one and done there. Pilot, again, you have a little pilot testing period, and, pretty straightforward. Phased happens in phases. Parallel, the two things are basically going at the same time there. Okay, so a couple other methods for developing applications. We're not going to talk too much about these on the exam or anything, so don't worry about them. But basically, we have joint application development. And joint application development is a unique approach in which what we're going to do is we're going to sit down the developers, and we're going to sit down the stakeholders, and they're going to sort of have some sort of an agreement on what the system should do. Now, how does that differ from the SDLC approach? Great question. In SDLC, it's generally thought of that the meetings are going to be somewhat more sporadic and certainly going to be less focused on having everyone agree and more focused on just gathering that information and then sort of forming a consensus later. So in the joint application development, everyone's in a room together basically, and they're sort of having some sort of an agreement where they all say, yes, this works for me. Rapid application development is going to be somewhat of a dangerous approach actually, because what you're doing is you're making changes that are going to be very small, but you're not testing them on some sort of a production, or you're not testing them rather on some sort of a testing environment. Instead, you're running all these tests on production. And what could go wrong with that? Well, anything. So that's why this is a dangerous approach. It's always going to be I'm not going to say always, but generally speaking, it's going to be a bad idea to engage in a lot of testing on production equipment. So if you have a production server that you're using, it's hosting your organization's ERP, for example, and you run a test on it. Let's say that you have something done incorrectly inside of whatever you're testing. What could you do? You could wipe out your entire customer database. You could reverse all transactions. I mean, there's no limitation as to what could be done incorrectly. So I would advise against it personally, but some people really like this approach. Probably works better if you have an easy way to reverse any change. But even then, it looks really bad if you're sitting there reversing changes all day. So make of that what you will. Last, we have the agile approach. And inside the agile approach, what we're doing is, like with rapid application development, we're focusing on little bits at a time, but unlike it, we're focusing on these inside of a more testing-oriented environment. So it's a much more advisable approach to take for development. And then lastly, talk about a couple of these system development tools. Prototyping could be a very effective way to kind of show people what you have in mind. Showing people a diagram, some people may understand it, but not everyone will. If you show them a system that mostly works, that's going to get a lot better feedback in most cases, because people can kind of grasp it. They can kind of see, yes, this is how it will work, or they can say, well, you forgot this part right here. It's a lot easier to kind of see. Of course, we also have things like computer-assisted software engineering tools. Generally speaking, when we think about these, what we're talking about is tools that we have to make developing applications more simple. Probably the most famous example of this would be something like an integrated development environment, where it basically, as we're coding things out, it's going to make suggestions to us. It's going to tell us why something isn't working. Lots of good suggestions like that. It's going to help out with variable naming, all that sort of stuff. It also greatly helps out with documentation. So if we're writing code and we're putting comments in it appropriately, those comments can be automatically applied to documentation for the software. That's going to be a really big advantage, because documentation otherwise could be pretty time-consuming and cumbersome for an organization to engage in. Then lastly, of course, we have object-oriented development. This is going to just kind of contrast with more traditional approach of procedural programming. It's going to save some time on development in terms of not having to develop each and every thing as it will be accomplished. Instead, we can kind of call into existence objects. Again, not a big focus of this class, don't worry about it. One last thing for today, we are going to cover Technology 2 Guide software. So next class, we will do the review for Unit 2. So just a couple quick slides here. Basically, what we're going to be talking about is defining software. So at the most basic level, software is just going to be some sort of an instruction set that tells your hardware what to do. So if we don't have software for a piece of hardware, it's not going to do anything. It's just going to sit there. So the software is going to be what's going to define what the application will do. And when we think about software, generally speaking, this could be any sort of written instruction set. But generally, we're going to think about a computer application of some sort. It could be a mobile application as well. But basically, we want to make sure that we're thinking about the software in terms of being something that's going to be run. So we also, of course, want to talk a little bit about software defects. Make sure that you don't run into any of them, of course, if possible. But generally, there will be some software problems. And if there are software problems, you could have lots of sort of downfalls with those. You could probably imagine some of them. The most basic ones would be incorrect data. Think back to the CIA triad. If we have data that's inaccurate, we don't have integrity inside of the data that we have for our organization. And that's going to be a very substantial problem, because that means that any sort of information we would gather could be wrong. And in fact, it will be wrong at a more basic level. So that's certainly something to avoid. And then lastly, it's a big consideration to make sure that the software that you have is going to allow it to be used in whatever sort of way that you would anticipate it being used. So I've got an example here from Apple. I'm pretty sure this is their iTunes license, yeah. So you may be thinking, what if you are a nuclear power plant? Looks like they might have taken that out. Let's just see here. I think we need to go to the English specific instructions. Looks like this is not searching the right thing here. Okay, well, it used to be they had a clause in here. I didn't check it before class today. I probably should have. They used to have a clause inside the iTunes license that would prohibit you from using the iTunes if you were developing any sort of thing involving nuclear or missile technology. So that's kind of an interesting thing. You may think you can play your songs on iTunes inside of that environment, but in fact, it's prohibited by the software license. Now, is that going to be enforceable? Probably not. But you could certainly run into a legal battle if it were going to be discovered. So that's where it goes back to having all that information inside the software catalog and having a team that's going to be dedicated to ensuring compliance with whatever sort of licensing you have, because that can cost millions of dollars for an organization to use the software not according to the license. Kind of talk a little bit more about the applications themselves. So basically, what we have here is we have the user typically can interact with the applications, in terms of using whatever sort of things they're using. Maybe it's a web browser, office applications, whatever they're doing. You're going to be interacting with them directly, and then those are generally speaking going to interface with the operating system. So most of the time, for traditional computing devices, it's going to be Mac or Windows. Of course, there are others as well, also mobile platforms, but generally speaking, that's going to be how it's going to interact. And the operating system is going to interface with the hardware itself. Of course, there could also be some system software below the operating system, but above the hardware. That's certainly going to be some consideration to keep in mind, things like drivers, anything like that. So just kind of wrap things up today. We've talked about planning for IT. We also covered various sort of software that we could obtain, how we would actually go about that, and then we covered developing the software ourselves. Any questions about today? All right, well, that's all I have today. I hope you all have a great day. Don't forget to do the quizzes.